They say the universe is infinite, but is it really? We've launched spacecraft beyond the edge of our solar system, yet compared to the scale of the cosmos, that's like walking one step in a 1,000-mile journey. So, how far can we actually go into the universe? And what's stopping us from going farther? Let's unlock that mystery. Our universe is about 13.8 billion years old, but the observable universe, what we can see, is much bigger, roughly 93 billion light-years across. Wait, how can we see that far if the universe is only 13.8 billion years old? Because the universe is expanding, not just matter moving through space, but space itself stretching. The light we detect today from distant galaxies was emitted billions of years ago, while the universe was much smaller. As that light traveled, space kept growing, so the distance between us and those galaxies increased, even while the light was in transit. What we can observe is limited by the cosmic speed limit, light. Anything beyond that boundary is in permanent darkness. It's not invisible because it doesn't exist. It's invisible because light from there hasn't reached us, and maybe never will. Let's say we wanted to travel out there, to the edge. What's stopping us? First, the speed of light. It's the ultimate speed limit. Even at that speed, it would take over 4 years just to reach our nearest star, Proxima Centauri, and hundreds of thousands of years to leave our galaxy. Our fastest spacecraft, Voyager 1, it's been traveling for over 45 years, and it's barely outside the solar system. Now, here's the real twist. The universe is expanding faster than the speed of light. That doesn't break physics because it's not objects moving through space, it's space itself expanding. This means some galaxies are already moving away from us faster than light. We will never reach them, no matter how fast we go. They're disappearing beyond the cosmic horizon, forever out of reach. But humans don't like limits, so we imagine ways around them. What if we didn't travel through space, but folded space instead? What if we could jump from point A to point B without crossing the space in between? Welcome to the world of theoretical physics. Wormholes, tunnels through spacetime, potentially linking distant regions instantly. Warp drives, like the Alcubierre drive, a concept where space is compressed ahead of a ship and expanded behind it. Quantum tunneling, jumping across barriers using quantum probabilities. Sound like science fiction? Well, it is. For now. We have no evidence that wormholes exist or can stay open. Warp drives require negative energy, something we've never created. Quantum tunneling works on particles, but a spaceship? That's a different story. Still, these ideas are important. They show us that the universe might not be limited by speed, but by how we think. But maybe we're asking the wrong question. What if the real limit isn't how far we can go, but how we define distance? In quantum mechanics, particles across the universe can be connected instantly. In general relativity, time and space are part of the same fabric. And in the vast scale of the cosmos, our human concept of far might not even apply. What if the real frontier isn't light years away, but right here, in our understanding? We may never reach another galaxy, or see the true edge of space. But in our search, we discover something deeper. That curiosity itself might be the greatest journey of all. And that is the key to the unknown.